Okay. Let me know when we can move on to the next one here.
We're all good.
All right. So next one, again, they have to give you a term. Okay, this one's a little different because they're using sort of function notation instead of subscript notation. Okay, but they're giving you kind of it's the first term, but if you were to learn about programming, you might call this the 0th term, meaning it's at 0. So the key thing though is to recognize that, well, what's the next n value? It was 0, but what is the new n value? It's when n equals 1. Whereas in the previous problem, we actually started, they gave you 1 and then you had to find the second. So you have to pay attention to these indices to make sure you're aware of which is the next term. Okay, so that means f of 1, because you're using this second equation now, equals 2 times f parentheses 1 minus 1. And this is 2 times f of 0. Is that okay? Is that need more
Yes.
explanation? All right. So f of 0 is what's given. That's where you eventually do substitute in for the thing that was given. It's 2 times 4. Like f of 0, let me just highlight this whole thing. This f of 0 is the 4. Like it literally takes the place of that. So this is 8. And so again, it might be good to come off to the side and sort of make this list like, okay, f of 0 is 4, f of 1 is 8. Because sometimes you notice a pattern. So now let's let n equal 2. And again, I'm going to use that second equation. F of 2 equals 2 times f of 2 minus 1. And that's 2 times f of 1.
Yes.
Right, and that means it's 2 times, and that means it's the previous one, which is 8. 2 times 8 is 16.
Right.
So f of 2 is 16. This is where you got to be careful, because if you thought it was just double or like plus 4, you would see that doesn't work. You might start to notice a pattern here, times 2 times 2. We'll see if that continues here. But that's what you're kind of looking for until you know otherwise.
So what's the difference with like whenever, so on number 3 it was saying like a1 equals 1, and then on this one it's saying like f of 0, like does that make a difference at all?
Well, the typical problems that you would see are they use these subscripts. Your book is choosing to also use this function notation. The typical way of presenting it is this way. Like when you look at your in-class notes, did you see any function notation from your instructor?
Let me see. We just learned like geometric and arithmetic sequence, like equations or rules.
Right, but they were probably not written in function notation. Like they
Probably
were
not.
using these subscripts. So like the short answer is, like, you probably shouldn't worry too much about this because this is not typical, but it is allowed. It's just your book is choosing to mix 2 different types of problems. It's kind of detrimental, I would say, but like there's no difference, even though it looks different. So I think doing a few more, we can make some more sense of this, but try not to overthink it for the moment.
Yes. Okay. I'm just writing one more thing down.
And so I'm gonna write out one more of these before we just say, oh, we've got the pattern down. Because you don't want to write the formula every time if you don't have to. You want to almost do it in words. Double the previous one, double the previous one, double, double.
All right.
So like I feel pretty confident at this point saying we can just double the previous number each time. And write out the answer.
Okay.
Any questions on this?
No, I think I'm good.
Okay. All right. So for 7, it would be good to try to do this one without writing out the terms and just like say in words what's happening in the formula here. So when I say that, I'm talking about this line here. Like the formula says, it says square the previous term. That's what this a sub n minus 1 means. That's the previous term. Square it. That's the power of 2. Then add 1. It's very much like a recipe. It's like mix the eggs together, then add flour.
Yeah.
Okay. Now we could use the subscripts each time, but if you're comfortable with this, and your teacher will be okay with this, you're squaring 2, which is 4,
Mhm.
and then adding 1 to it, which is 5. So the third term, you're squaring the previous one. Then you're adding 1 to it. So if you'd like to show your work, it's 5 squared plus 1, which is 25 plus 1, 20, 26. And we could do the same thing for that previous one there. It just depends on how comfortable you are with showing steps or not showing steps along the way.
Yeah.
Now, I assume you're allowed to use a calculator. Why don't you calculate the next couple of terms for me here? I guess we got to, this is going to get pretty darn large. Or at least the next couple, if you don't mind.
Yeah. So 26 squared plus 1
Yes.
is 677.
Yes. And then it gets pretty large here. I guess the next one. I'm sort of shocked that they would let this get that large, but that is the case here. So last one is huge.
Yeah. Okay.
Okay, now for number 9, what I can do here is I can stop using the function notation and give it to you in the subscript notation? Would that be preferred, or do you want us to continue to use the function notation?
Either one works with me.
Okay, so let's stick with the function notation as given here. So let me try to explain in words what this line is saying. Take the previous term. Okay, so that's n minus 1. N minus 1 means previous, and subtract the previous term. Okay, and I know that's bad English and all that stuff, but this is an English class. It means like the one before it. Okay, so like if you were to make a list here, that's why sometimes it's better to write these out this way. The second term means to take the previous term, which is 4, and subtract the previous term, which is 2. And if you don't like that, I'll put the numbers in here and we'll look at it the other way. But that's probably a better way to do these long term.
Right. So then
it's
f of 2 is 2.
Yes.
Then
Okay. So up until now, the sequences have kind of made sense. This won't make as much sense with the output, because 3 means to take the previous term, 2, and subtract the one before it, which is 4. So what you can't do is look at the numbers and like try to pattern them. Be like, oh, it went up by 2, down by 2, it must go up. No, it's the recursive ones don't always have this nice flow to them.
right.
So then the fourth term here, I'm sorry, the f of 4, this is actually the fifth term. I meant to comment on that earlier, but you take the previous term and then you subtract the one before it, which is -4. So you're taking that -2, subtracting the one before it, which is 2. And that's your final answer.
Okay.
Will you find the sixth term for us, f of 5, and let me know what you come up with?
Yes. So it'd be -4 minus 1, which is -5.
-4 minus the previous
Or,
term.
yeah, that'd be -3.
This is the previous term.
Oh. Oh, okay. So 4 minus -2. So that'd be -2.
Yes. And so I know it doesn't ask for it, but the sixth term, could you calculate that for us just to see if it's clear, this process?
Yes, so then it would be -2 minus -4.
Good. Okay, that would be +2. And there might be some repetition here at some point, but not here. All right, so that's I mean, that's a quiz question. Here's the formula, write out some terms. You for sure will get something like that. Just keep in mind it's the first term, even if it indexes at 0, it's still the first term. That's the second. It's counting. Third, fourth, fifth, sixth. So you stop when it's the sixth term, even if you're not up to 6 in the indice. All right, if that's clear, we can move on to number 11.
Yes.
Okay. So I think numbers 11, 13, and 15. I think these are really tough because they're not really mathy. They're pattern based. You have to determine the recursive rule, and you have to look at this as like, how do I get to 14 from 21? Basically, how do I use the previous number to get to the next one?
You subtract 7.
Yes. So question is though, does that work? Like to get to 7, from 14, does the same thing work?
Consistent.
Yes. In this case, it does. And that's really good. Okay. So this is where it's a little bit hard to write the rule because it's almost easier in words. It's the next one is the previous one minus 7. Is that okay with the words?
Yes.
Okay.
Yeah.
Now, in terms of like, what can we use for indexes? Well, there's a couple of options. So this can mean the next term, and then the previous is n minus 1. So like that's one option. That's kind of what you've been seeing in your problem sets here. The other one would be to use the function notation.
Yeah.
So it'd be like f of n equals f of n minus 1 minus 7. Those would be okay. Now, what you have written is not complete because you always have to give the first term. Okay, you have to somewhere add in that, and I'm just going to say that A1, the first term is 21. And then you write the recursive sequence. So it's not enough to just give the formula. You have to also give the initial, what's called the initial condition or the seed to the sequence.
Yes.
So when they're linear like this, they're very easy to write. Okay.
Right.
It's when they are not linear
Yeah.
that they're a little bit more difficult. Now, in the case of 13, you still can see the pattern. It's not overwhelming. And how you do this is you go through the 4 math operations: plus, minus, multiplication, division, and you check the boxes to see like, well, like, am I adding the same thing? Am I subtracting the same thing? Am I multiplying the same thing? Dividing? Like you just go through this progression and hopefully one of them works. So that's sort of my question. Have you spend 60 seconds on here is to decide like, does the same thing work each time? Whether it's addition, subtraction, multiplication, or division. And keep in mind, addition and multiplication are used when it gets larger, bigger. This is for smaller.
So it's multiplying by 4 each time.
Yes. Okay. And it's the previous term times 4. It's 3 times 4, then it's 12 times 4, and so on. So again, in words, it's like the next equals the previous times 4.
Yeah.
And then it's now mapping those words to indices, or something that's more meaningful, like an minus 1 times 4. And then just for preference here is you put the number first. So it would be 4a sub n minus 1, and like that. And just like in the previous problem, you have to give the initial value. You have to say
Right.
what the first term is. You have to give it that it's 3.
Yeah. Okay.
Got it down?
Yes.
Okay. Okay, so take a look at this next sequence of numbers and be wise to make the list here and see if something stands out to you.
It's dividing by 4 each time.
Yes. Yes, so that really helps. Divide by 4. You can also think of division by 4 as multiplication by 1/4.
Yes.
If that's a more comfortable way of
Yeah.
viewing things. But just like in the previous problem, it's next equals previous, divided by 4 or times 1/4 or something like that. So this is something like an equals an minus 1 divided by 4. And then you have to give the first term. You say, all right, you start at 44. So I would generally say the first term should be n equals 1. Try not to mess around with n equals 0, and look for these sort of patterns when you're doing this.
Right. And then could you also do like an minus 1 times 1/4?
Yes.
Okay,
Yes,
so I
that'd
can
be
do
good.
both ways.
Let me know when we can move on to 29.
You're all good.
All right. So the instructions in 29 say to write a recursive rule for the sequence. And a lot of ways math is like when you get a new problem, you turn it into something that's old so that you know how to do it. So for this problem, you're going to write out the terms. Okay, so you're gonna like say, okay, well, if n is 1, what is the term? What does this become? Can you tell me that?
If n is 1,
Yes.
oh, so then it'll be 7.
Right. And then if n is 2, I'll do this one. It's 11, excuse me. What about when n is 3?
15.
Okay. N is 4 is 19. And so you do this until you see a pattern. So do you see a pattern?
We're adding by 4 each time.
Yes. So notice this is just like the previous problem because you now have enough terms to write a pattern. So I want you to try writing the recursive sequence formula here. And let me know what you come up with.
So A1 would be 3, or A1 would be 7.
Yes, A1 is 7 for sure.
And then the rule would be an equals an minus 1 plus 4.
Yes, perfect.
Okay.
All right, so 31 is really similar. So I'd like you to try this one start to finish, and then I'll help going forward with the next ones. But I'd suggest writing out a few terms, looking for the pattern, and then writing the rule from there. And just if you have any questions, please ask along the way.
So would it be an equals an minus 1 plus 10?
Like this?
Yes.
Okay, so
Or is it minus 10?
well, so before I answer that, give me a few terms here. Like, what was the first term?
2.
Okay, and what was the second term?
Second term was -8.
Okay, and then the third term?
Third term was, let me see. It was -18.
Good. So what is the pattern here? And you can say it in words or give me a math operation.
You're subtracting 10.
Subtracting 10. Okay. So to answer your question, it is subtracting. Okay. Is this everything you would put in your final answer if this were graded?
A1 equals 2.
Yes. So this is now correct. Okay. And you've got to include that first term, and you got to get the, minus 10, and that's why I was going to ask you, well, maybe it's easier to say in words, like going down by 10, which means subtraction. But yeah,
Yeah.
that's perfect. Okay. All right. So 33, we'll do this one together because this is new. This is actually a geometric sequence, believe it or not. You said you covered those in class a little bit, or?
Yes, a little bit.
A little bit. Okay. Now, again, we're just going to write some terms. So A1, or the first term, is 12 times 11 to the 1 minus 1 power. Okay, this is why you learned your exponent rules. 1 minus 1 is 0. 11 to the 0 is 1. This is 12. Okay. A2, 12 times 11 to the 2 minus 1 power, which is 12 times 11, which is 132. And you probably need to do 3 minimum, 4 max, I guess, to determine patterns. Depends on how comfortable you are with this. There's a lot of uncertainty when you see this for the first time. So then if you need to go to the calculator, I do need to go to the calculator on this one. 1,452. And there's enough here for me to see a pattern.
Right.
And it's times 11. It comes from the problem. It's not going to be some mystery value. There's a reason it's times 11.
Yeah.
Okay, so don't feel like there's some like, somebody's got the this crazy math expertise. They're just looking for the number that's already there. That's actually one of those things I would talk about in the SAT class on free response questions. Like, sometimes the answer is just right there. You just have to believe that is what it is.
Right.
Okay, so this is enough to write the geometrics. I'm sorry, to write the recursive sequence, I think. Would you try writing the formula out, giving that a shot?
So A1 is going to be 12.
Okay.
And then AN minus or equals AN minus 1, and then times 11.
Yeah, so your book would show it as 11 times AN minus 1 as a preference.
Yeah. Okay.
So we'll just write out a few terms again here. So A1 is 2.5 minus 0.6, which is 1.9. A2 is 2.5 minus 0.6 times 2, which is 2.5 minus 1.2, which is 1.3. And then A3 is 2.5 minus 0.6 times 3, which is 2.5 minus 1.8, 0.7. this is enough to see a pattern. And we'll talk about some summary after this question.
So it's subtracting 6.
0.6 each time.
0.6, yeah.
Yes. And you know, you either have to look at that as subtracting 0.6 or adding 0.6, negative 0.6, whatever you prefer. But you should notice that, see how this one's linear? It's like a linear equation.
Yeah,
And 31, do you see how this was also a linear equation?
yeah,
And same with 29.
yeah.
And that's why they always had these nice, you know, add 4, subtract 10. This one's minus 0.6. Okay. So why don't you write the rule for us on this one and let me know what you come up with.
So A1 is gonna be 1.9.
Okay.
And then AN equals AN minus 1 minus 0.6.
Yeah, perfect.
Okay.
Okay, so now let's go to 37. We should be able to get through everything today. Again, like try not to get overwhelmed when you see fractions and exponents. Like just go through the motions, you know, put the number in for n and see what happens. And if you have a calculator, you can enter this in the calculator. Like if you're just totally off, you know, just feeling like I don't know, you will want to convert this to fractions. So if you do use a calculator, you can hit the math enter button, and that'll convert it to a fraction. If you didn't already know about that one. So go ahead and give me a few terms here if you don't mind. Let me know what you come up with.
I got 0.5, negative 0.5.
Okay, so I'm going to go negative 1/2.
Yes.
Okay, give me the next one here.
I got negative 0.125, but as a fraction, it's negative 1/4.
Should be yes, sorry, I was going to say something else, but yes, that is correct. Okay, and will you go ahead and do one more for us, please, and give me the fraction this time. No more decimals going forward on this problem.
Okay. Negative 1/32.
Try. No, you're right. I'm sorry, you are right. So this one. Sorry, let me just check here. I'm sorry, I'm not seeing what I want here.
That just looks really high.
Yeah.
But
I was expecting you to say. So let me just check here. Sorry. This should be 1/8.
yeah. Oh.
Okay.
Oh yeah, it should be.
And then this one is negative 1/32. That's fine now.
So we're multiplying by -4, or
Yeah.
just regular.
Negative 1/4.
Yeah.
So if you don't mind, just use the calculator one more time, because this one, I think you need a fourth term to see the pattern, but just so I can, because if I need to, I can show you how to use that fraction feature, but try this one more time to give us the last one as a fraction.
-1/128.
Yes. Okay. And so like when it's adding and subtracting, it's not that hard to kind of like figure out, well, what is it that you're adding and subtracting by? For the division ones, you can take the next term and divide it by the previous term. And that will often tell you what's going on.
Oh, okay.
So like you already told me, and I think you see that it's times 1/4,
Yeah.
but you can also take -1/8. You just got to be careful with how you do that in the calculator, because the calculator won't always receive this format here. So if you are comfortable with this in terms of your calculator, you may have to go -1/8 in parentheses / -1/2 parentheses in the calculator.
Right.
But you should get times 1/4. Okay, so this does give us the geometric I'm sorry, the recursive sequence. First term is -1/2. The next term is the previous term, an -1 times 1/4, like we just discussed.
Yes. Okay. Okay, I'm good on that one.
Great. So that grouping of questions we got knocked out. We're up to, sorry, I'm just chat. So 41 through 45. And let's see what we got here. See if it's more of the same. Excuse me. I don't have a page for that picture of that one. If you can send that over real quick.
Oh, it's not part of that one.
It did not come in.
Okay, let me see real quick. Oh, it got cut off. Okay, I can send that real quick. Okay, it's sending, it's loading.
Okay. Do you have off from school tomorrow?
I do.
It's awesome. Anything fun planned?
I'm going prom dress shopping with some friends and my mom.
Nice.
Yes. But I'm very glad I don't have school tomorrow.
Yeah, I had a parent ask me if I was working tomorrow. I said, yeah, sure. I didn't even know I didn't even know there was a holiday.
I didn't know there was a holiday until like Friday.
Yeah, and it's nice, an unexpected day off here. All right,
Yeah.
did that send? I'm regularly checking here to get this.
Yeah, it's it's like it's taking the load of the picture,
Okay.
but I think it's about to send right now, actually.
All right.
So
What
like
what are
5
what are
seconds.
what are the instructions for 41?
It says write an explicit rule for the sequence, and I just sent it over.
Okay. There it is. Okay. I got the same. Nope, there it is. There it is. Okay, sorry, spoke too soon. It's like, okay. All right, so this is good here. We these won't take too long. We're gonna write out some more terms for this. So the just like we did in the previous problem. So the first term is 3. The second term or the next term is the previous term minus 6.
Right.
So it's 3 minus 6, which is -3. The third term is the previous term minus 6 minus 9. Okay. And what we're supposed to recognize here is that this is arithmetic. Okay. So they want you to basically write the arithmetic sequence.
Okay.
Okay. So your A1 is 3. Okay, that's what's given. And then your N is your variable. D is the common difference. So it's like, what are you doing each time you're subtracting 6?
Okay.
And then you do have to simplify here. So it's 3 plus -6n plus 6. AN equals 9 minus 6n. So just because we're short on time here, why don't you go ahead and get that down and let me know.
Yes, I got that one down.
Okay. So the idea is that the explicit rule means arithmetic or geometric, whatever it may be. Recursive is what was given, if that was unclear. So let's look at 43 really quick here. Try to get through all of these. All right, so 43, we're going to write out a few terms again. The second term means to take the previous term and multiply it by 3. So that means -2 times 3, which is -6. -6 times 3, which is -18, and so on. So you see the pattern here. You're multiplying by 3. Okay. Now, I guess you've already learned geometric, so I can show you that formula here. The geometric formula is A1 times R to the n minus 1 power. Your A1 is -2. Your R is that multiplication, and then n minus 1 is the exponent.
Yeah.
All right.
Okay.
So thankfully 45 is like 41. In the case of 43, get some more explanation in class. I really rushed through that. 45 though is much more like what we've been seeing. So the first term is -12. The next term is to take the previous term and add 9.1 to it. So -12 plus 9.1, which is minus 2.9. The third term is to take the previous term and add 9.1 to it, which is 6.2, I believe. Okay, and then there is a pattern. The pattern is you're adding 9.1 each time. Sorry, this is not right. This is 6. Yeah, that's not right. Sorry, let me grab a calculator here. Minus 2.9. 6. So it is 6.2. I guess I did have it right.
Yeah, I think that was right.
Yeah. So the formula again is this one's arithmetic. So it's AN equals A1 plus N minus 1 times D. A1 is -12. N is your variable. Your common difference is 9.1. So you distribute in 9.1N minus 9.1. So it's minus 22.1 plus 9.1 n is your formula there.
Yes.